right, this is 4.1, probability basics. Our two goals today are to distinguish between theoretical and experimental probability and to determine theoretical probabilities given equally likely events. First of all, talking about theoretical probability, we have this definition here. Given the image of all possible outcomes for rolling two dice, we can determine the theoretical probability of finding any given sum from blank to blank. What's the lowest sum you can get when rolling two dice? Alia? 2. And the highest sum, Toby? 12 is correct. Now this first example says, what is the probability of rolling a sum of 8? So, it's kind of nice. I already have the visual here of all the possible outcomes. So all I need to do, I'll circle the ones that have a sum of 8. You'll notice this one right here has 2 plus 6 has 8. And then the one directly diagonal also is a sum of 8, 3, and 5. 4 and 4, 5 and 3, 6 and 2. And I can actually write that with some curly braces and some ordered pairs here. 2, 6, 3, 5, 4, 4, 5, 3, and 6, 2. This is called a sample space. This is something we will talk more about in our next lesson. It's just the list of all the possible outcomes within a given event. The event here being the sum of 8. So step 1 in this process is actually to find the total possible outcomes. How many ways can two dice be rolled? Who's got the answer on that one? If you count all these up, how many are there?
36.
36, yes. So there are 36 total possible outcomes, and we've just written out a sample space of how many ways we can observe the given event of a sum of 8. So that would be a total of 1, 2, 3, 4, 5 out of 36. That's it. That's the probability of rolling a sum of 8. Step 3 is to simplify. So you always want to make sure you simplify your fractions. A probability can be written as a simplified fraction or as a decimal. So the decimal equivalent of 536 would be just dividing 5 by 36. We'll round to 3 decimal places as a standard in this lesson. So everybody get your calculators ready. 5 divided by 36, we'll have a little calculator wars here. 0 point, what did you get? 3 places, 1.
0.13, but round it up to 0.14.
Go to the next spot, and then look to the 4th spot to see if it stays the same or goes up.
0.139.
You got it. 0.139 would be the decimal equivalent, so either one of those answers would be an acceptable way to write the probability of that event occurring.
Is that in that line?
No,
Okay.
I just wrote too big on step 2. My bad. In the example above, notice that all chances are, this is a phrase that comes up quite a bit, equally likely. To occur. Notice that we called rolling a sum of 8 the event. It is an event. So the probability of any event is just this little ratio here. The number of ways the event can occur divided by the total number of possible outcomes. It's very basic. So basic, some people tend to overthink it. So come back to this to refresh your minds. It's just the number of ways an event can occur divided by the total number of possible outcomes. It is important that the scenario allows each event to be equally likely, or each outcome to be equally likely to occur. The science of uncertainty. To me, it's such an interesting thought. There is a science of uncertainty, and it is called probability theory. Probability theory provides the mathematical basis for inferential statistics. Recall inferential statistics is used in making decisions based on the likelihood that an event will occur. There are 3 properties of probabilities. Start with Dylan, will you read property 1, then Ganesh, then Jax.
The probability of event is always between 0 and 1.
That's important. Probability has to be between 0 and 1 inclusive.
The probability of an event that can occur is 0. An event that cannot occur is called an impossible event.
Excellent. Cannot occur. That means the probability is 0. It's also called an impossible event. Property 3? Excellent. Probability that it must occur. That's going to be a probability of 1. It's called a certain event. So for example, if I said there are currently 9 students in the classroom, 9 of them are wearing shoes right now, the probability that I choose someone at random and check to see if they're wearing shoes would be 1. 9 out of 9. The chances are certain. If I look around, I said, what's the probability of me selecting a student at random that is in the 7th grade? 0. 0 probability for that. This is all 11th and 12th graders in the room. Yes.
Would it be like a decimal, like in between 0 and 1?
Yep. Your probabilities are most often a decimal, like we had here with the outcome of,
Oh.
with the event of rolling a sum of 8. Okay, so which of the following could possibly be a probability? We have 5, 6. Could that be a probability? Yes, that's correct. That's between 0 and 1. 3.5.
No.
Nope, that's bigger than 1. 0.
Yes.
Yes.
Wait, yeah.
That was like 7th graders in the room. Not happening. Negative 1.5. No, it's negative. You get the idea. Example 3, will you read that one, please? Grayson.
An ordinary deck of playing cards has 52 cards.
It should say cards. That was a typo. I'm not sure who did that.
An ordinary deck of playing cards has 52 cards. There are 4 suits, spades, hearts, diamonds, and clubs, with 13 cards in each suit. Spades and clubs are black, hearts and diamonds are red. If one of these cards is selected at random, what is the probability of that?
Thank you. What's the probability that the randomly selected card is a diamond? The way that we can do this, like I said, if there's a question that is being asked of you within our context of Math Excel, it's going to give you the information about a deck of cards that you need. So if you're not as familiar with the deck of cards, you'll just read closely and you'll be able to figure it out. A diamond, we've already just read that there are 13 cards in each suit, so that would be 13 cards out of the total 52. That's the probability that I would draw a diamond. I would simplify that to 1 out of 4. And sometimes your answer is asked to be given in a fraction, a simplified fraction, and sometimes as a decimal, we'll leave it as a fraction.
Simplified in like 4 years.
Simplified fractions,
Yeah, it's been a while.
there's a button on your calculator if you just type it in, like 13, if you get your calculator out, you just type 13 in the ABC button, the fraction button, and then 52 and press equals, and it simplifies for you.
Seriously?
But I can also do a fraction simplifying refresher after these names. Red. There are 26 of the cards. There's diamonds and hearts. 13 plus 13 is 26 out of 52, and that simplifies to 1 out of 2. Thanks, Toby. And not a heart. Not a heart. There are 3 suits that are not hearts. That is 13, 13, and 13, which is 39. 39 out of 52 of our cards are not hearts, which is 3/4. Good. Either way. Okay, good. On to the back. Will you read for us, please, Jade?
The following table provides the frequency distribution for the number of rooms in this country's housing units. The frequencies are in the thousands. A housing unit is selected at random by the following probabilities.
Thank you. So that part got cut off, so we're just going to add it in. Probability that the housing unit has 4 rooms would be, first things first, you got to add these all up. And when you do, you get 120,815. So to find the probability that the housing unit has 4 rooms, we're going to put what number over 120,815? Raise your hand when you know. Bryce? So how many of the units have 4 rooms?
23,361.
Excellent. So we write that down, and then that was just from this line right here, 23,361. You can type that into your calculator, divide numerator by denominator, and get a decimal. Ganesh?
0.19 and then 3. So 0.1. My bad. That's not how I read it.
Perfect, thanks. 0.19 and then a 3.
0.19.
B, 2 or more rooms. So again, we're going to put a number over the total, which is 120,815. What's the number that goes over the total?
120,240.
120,240. And how did you get that, Jade?
I just subtracted 575.
It's a good strategy. So some of you might have started adding all of these together, adding those that had 2 rooms, 3 rooms, and all the way on up. And if you did that, you would get this same number, 120,240. A quicker way to do that would just be to subtract 575 from the total. It's going to get the same answer. And then when you divide numerator by denominator, what do you get for that one? Ganesh?
Is to be 9. No, is it gonna go round up to like an actual 1? Is it gonna become 1? Okay, then 995.
Yes. Well done. 3 decimal places, 0.995. C. There's D parts, just 2 more. What is the probability that the unit has fewer than 1 room? 1 room. Zero. What do we call that? Impossible event. Well done. And part D, what is probability that it has 1 or more? Yes, the probability is 1. We call that a what kind of event? That's right. This one is certain. All 120,815 units have at least 1 room. Experimental probability is different than theoretical probability. We're mostly talking about theoretical probability, but it's important to note that experimental probability is when we're doing an experiment or simulation and then calculating the probability. That's what's called experimental probability. It's also known as simulated probability. That's where our real world factors play into this type of probability, including gravity, friction, economy, weather, etc. If I had everybody in this room flip a coin 100 times, the theoretical probability is you get how many heads? 50. But if we all did that as just an experiment, then most likely we would get something close to that, but not exactly 50 and 50. So there's the difference between the experimental versus the theoretical. We've got two more examples. Example 5, will you read that one, please? Alia.
Right. A polling firm hired to estimate the likelihood of the passage of an upcoming referendum. Obtained the set of the survey responses to make its estimate. The inputting system for the data is 1 equals 4, 2 equals against. If the referendum were held today, find the probability that it will pass.
Thanks. 1s mean for, 2 means against. How many total votes were there? 20. Good. So we've got 20, and how many of those were for the referendum? That means how many 1s are there? 12. Good. 12 out of 20, we could simplify that fraction. We're going to write it as a decimal. 12 out of 60. 3 over 5 if we had to simplify the fraction, good, or 0.6 if we convert it to a decimal. That last one, example 6, I want you to try it on your own. You can do it.
Sorry, y'all.
Well, you call that same time as me.
You coughed? Girl, I had a little
Solid ice is 10. Raise your hand when you've got it. We'll write it as a decimal rounded to 3 spots. Okay, what'd you get? One more, please. Three. Great. There's 3 ways to roll a sum of 10. There are 36 total possible outcomes, the reduced fraction, and the decimal. So that concludes our notes. I'm going to have everybody open up Math Excel and go to question number 9. I'm going to actually help you walk through question number 9.